Hello, this is John from caveofprogramming.com, and in this tutorial we're going to look at quantifiers, and we're going to look at the idea of a greedy versus a non-greedy quantifier in regular expressions. And before you look at a more interesting video, let me explain that quantifiers are one of the fundamental building blocks of regular expressions, and that if you learn a few basic things like wildcards, groups and quantifiers, you'll be able to do really a lot with regular expressions. So they are well worth learning. And although my original plan for this course, as stated in the first tutorial, was to try to give you something directly useful in every video, well, this stuff is directly useful in the sense that you'll need it to do anything much that involves regular expressions. So we've already seen that you can use dots as a wildcard in your regular expressions, and I've got this little program here that's it opens a file, it reads it line by line, and for every line it applies a regular expression, and if it matches that expression it prints the line out. Let's just change this from the last tutorial to say print $line. So let's say, for example, I put dog in here, and my input file is actually the book My Man Jeeves by P.G. Wodehouse from Gutenberg.org. Then we can see that we've got a bunch of lines that in every single line have the word dog somewhere, even if it's part of another word in this case. Now, suppose you want to match one or more of a certain character. Let's take an example like L. So this by itself will just match one character, and in fact what I'll do here is I will use groups. So as we saw in the last video, if I put round brackets around this, I can then print out here only the stuff that I matched by writing $1 \n for a new line. So what this is doing now is this regular expression here is only going to match L, because that's what it is, it's the character L. And these round brackets say whatever was matched by the stuff inside the brackets, then put that into the variable $1, which is kind of a special variable in Perl, and it's $1 as we've already seen, because there's one pair of brackets here. So we're printing out $1, and if I run that, it's going to give us a load of L's like this. Now supposing I want to match well, let's say one or more L's for a start. Then what I can do is I write plus like this, and plus means match one or more of the preceding. And if I run that, sometimes we get one L, and sometimes here we've got two L's if there are two together. Probably not the best example, but it's a start. And the plus here is called a quantifier, because it's quantifying how many of the preceding character we match. And I think what I really want to show you in this video is the star quantifier and star question mark. So plus we'll definitely come back to, but dot, using star, particularly with dots like dot star, is probably the most useful of them all. So let's take a look at that. So I'm going to construct a regular expression here. Let's now, what kind of characters are most likely to be several in a row in some text? I suppose probably O. We might have, for example, the word soon or sun. Let's look for sun in there. Okay, so we've got sun, and let's look for soon. We must have soon. There we got soon. Now supposing I want to match 0 or more O's, so I could say, so I've got O there already, and I want to say match 0 or more of those. In other words, I want you to match SN, that's 0 O's. I want you to match SON, that's 1 O. I want you to match SOON, that will be 2 O's, and any number of O's, so 0 or more of them. Then I could put this, I put a star, and star says match 0 or more of the preceding character. So if I run this now, then I get SN I'm matching SN, that's 0, and you can see I'm matching 1 O, and there's going to be examples in here somewhere of 2 O's, and if there were rows of 3 O's in the file, which there probably aren't, then we would match those as well. So asterisk here is the most useful quantifier, and it means 0 or more of the preceding. Now let's try that with a dot, and you'll recall from a previous video that dot means any character, so a dot can match absolutely anything, including space. And I want to ask you, what do you think will be matched if we write s dot star n? Well, we know that SN can be matched. That will match that because asterisk means 0 or more of the preceding character, and the preceding character can be anything. So 0 of it would just be an S followed by an N with nothing in between. And it's going to match stuff like sun and soon. Let's run it and see what happens. And what we get is, surprisingly at first, we get massive long bits of text. And what's happening here? Well, what's happening, if you look carefully, is that the stuff we're matching, it always does start with an S. So that starts with an S. Well, they all start with an S, in fact. And it always finishes with an N. So this stuff inside the brackets, the stuff we're matching, we've said it must finish with N. And so it always does. There's always an N on the end here. But there's a lot of stuff in the middle, because we're saying match 0 or more of whatever's in the middle. But if you look carefully, we'll find examples where we could have matched less. So look at this. We could have matched, you'd think, this bit here. That starts with an S. It's got 0 or more characters, 0 or more of any character between the S and the N, and it finishes with an N. Why didn't we match that? And the answer is that an asterisk by itself is greedy. And what that means is that it tries to match as much as possible. So in each line, we're saying, find an S, match any character after the S, and match as many of those characters as possible. It could be 0, but as many as there are, try to match them, and then finish it with an N. So these are kind of, you can think of these as being kind of separate conditions, of saying it's got to start with an S, whatever we match. It's got to finish with an N, and it's got to have 0 or more, but as much as possible of other characters in the middle. And the as much as possible comes in because the star is greedy. It matches as much as it can. And that's almost all that I want to show you in this video. And dot star is a very, very common, very useful pattern, because of course it can fill in for anything. And the star is the most useful of all the quantifiers, and the dot, I would say, is the most useful type of wildcards, although we will see other examples of wildcards as we go through these tutorials. But now, what do you do if you want to stop it being greedy? And the answer is you append a question mark. So dot star question mark. Now the quantifier here is the question mark is the star and the question mark together. And star question mark, this quantifier, it means match 0 or more of the preceding character, which here is the dot wildcard, any character. But it's no longer greedy, it means match as little as possible. So the question mark there after the star changes the star from being greedy to not greedy. And now if we run this, we'll see that the lines are a lot shorter. And now we will never see a line that starts with S and has an N in it, and then there are more characters before the terminal N, because now we're always matching as little as possible in the middle, compatible with finding an S on the start and an N on the beginning, as you can hopefully see. So again, if you've seen these, if this is the first time you've seen these, then this is going to seem a bit cryptic, but if you practice writing this a few times, you will start to get the hang of it and see how it works. And the really important thing to fix in your mind here, among the stuff that we've seen so far in the way of regular expressions, is that dot means any character, and dot star means therefore 0 or more, as much as possible, of any character. And dot star question mark means 0 or more of any character, but as little as possible, compatible with matching the rest of the expression. So that's it for this tutorial, and you can find this code on caveofprogramming.com, and until next time, happy coding.